So that's what's shown in this picture right here is the slope of the secant line. Here you have the points A, f of A, B, f of B. The average rate of change is the slope between those 2 points. That's also called the average velocity. When you're looking at average velocity, by the way, it's the change in distance over the change in time. So here you're saying your y-axis is your distance, your x value here, x-axis is your time, okay? So finding average velocity of a falling object, again here, you're just straight up using the slope formula. The only thing you need to do here is evaluate at all the different x values to find the y values. So it says a billiard ball is dropped from the height of 100 feet. The ball's height s at time t is the position function s of t equals negative 16t squared plus 100. I'm just going to give you a little insight into this formula. You will see it later on. But this negative 16t squared, this always comes from the acceleration due to gravity. This 100 is because the ball was dropped from 100 feet. So if it was dropped from 50 feet, it'd be the exact same thing, except this would be a plus 50. So that's always your initial height that you add on there, okay? It says where s is measured in feet and t is measured in seconds. Find the average velocity over each time interval. So a couple of things that I want you to see here. When it says change in distance, well, in this case, it's measured in feet. In change in time, it's measured in seconds. So when we look at change in y over change in x, and this is an applied problem, we need to put units. And our unit for this is always going to be, in this case, for this problem, feet per second. Feet per second, feet per second. Okay. This problem requires absolutely no calculus because its average velocity, all it wants is the slope between the 2 points, not the derivative, not the slope at one point, the slope between 2 points. And to find the slope between 2 points, you need to know the points, right? So we know the x values. They're giving us the x values, 1 and 2, 1 and 1.5, 1 and 1.1. Notice what they're doing is finding the slope between 2 points and bringing those values closer and closer together. So I know right now that we're going to have to evaluate a lot of different y values into the same function. The function, I guess I should call them t values. We need to find a lot of positions, s values, for a lot of given t values, is what I should say here. So what I'm going to plug this into is negative 16t plus 100, the function, and I'm going to plug in every one of these x values that I see. So I see a 1, I see a 2, I see a 1.5, and I see a 1.1. So I'm going to go ahead and use my table feature on my calculator to get each of these y values so I can get the ordered pairs. I'm just going to get that out of the way right now. So I'm hitting table on my calculator. I'm clearing out whatever's in there. I'm going to type in negative 16, hit that x button, squared plus 100. So in my calculator it says y equals negative 16x squared plus 100. I hit enter. Start doesn't matter, step doesn't matter. Make sure you're on ask x and then hit OK. Now I'm going to type in my values. I'm going to hit 1, enter. When I hit in 1, I got an 84. I'm going to hit 2, enter. When I typed in 2, I got a 36. I'm going to type in 1.5, enter, and I got a 64. And I'm going to type in 1.1, enter, and it gave me a fraction. So I'm going to go ahead and hit the right arrow button to get to that number. It's 2016 over 25. I'm going to hit the double arrow button, which is just above enter, the little 2 arrows facing opposite directions above enter in your calculator, and it gives me the decimal version 80.64. So this gives me my points. 184, 236, 1.5, 64, and 1.1, 80.64. And why do I care about this? Because if I want to find the slopes between the graphs, I need the 2 points, and these are the 2 points that I have right here. I'm going to be looking at 184 and 236. Those are my first points. So when I do, for all of these, I'm going to do m equals, which is the average rate of change, y2 minus y1 over x2 minus x1. So that's what I'm doing on every single one of these problems, is I'm just straight up plugging it into the slope formula. So in this one, my average rate of change, give me 1 second. is going to be equal to the change in the y's, which would be 36 minus 84, over the changes in the x's, which would be 2 minus 1. Plug that into your calculator now, and let's see what we get. So I'm doing 36 minus 84. 36 minus 84 all over. And then I do 2 minus 1. I don't know why I did that because that's just 1, but that's okay. I'm getting negative 48. So what is the ball traveling at? The billiard ball is traveling at negative 48 feet per second. So what does the negative here mean? The negative just means it is going down towards the ground. The negative doesn't give me my speed. The 48 is the speed, right? The negative gives me direction. Okay, the negative is giving me direction. So velocity not only has speed, but it also has direction. 48 feet per second downward. Let's do the 1 and the 1.5. So again, the point was 184. And then when it was 1.5, we found out that our y value according to the chart was, give me 1 second to scroll over, 64. So I'm going to plug in the y value of 64 there. So that means my average rate of change would then be change in the y values, so 64 minus 84, over the change in the x values, which would be 1.5 minus 1. So let's do that on our calculator. I'm doing the fraction. I'm going to do 64 minus 84 in the numerator. I'm going to do 1.5 minus 1 in the denominator and hit enter, and I get negative 40. So this would be negative 40 feet per second. And now I'm going to plug in 1.1. Again, I want to remind myself of the points. It's 1 and 84. And then the second point was 1.1 and it was 80.64. Okay, so let's go in there and let's look at our average rate of change for this problem. Will be change in the y values, which is 80.64 minus the original one, which was 84, all over the change in the x values, which was 1.1 minus the original x value, which was 1. And let's see what we're getting. I'm doing the fraction button on my calculator. On top, I'm doing 80.64 minus 84. On bottom, I'm doing 1.1 minus 1. And I'm getting an average rate of change of negative 33.6. Okay. So the question then becomes, what is the rate of change not between these two intervals, not the average rate of change, what is the instantaneous rate of change at 1 second? And if you notice, we did 1 to 2, 1 to 1.5, 1 to 1.1. So we're taking those 2 points, finding the average rate of change between 2 points, but moving those points closer and closer together. Just like we did with finding this slope of the secant line to finding the slope of the tangent line. Find the difference between 2 points and bring them closer and closer together. So same concept there. And it says, suppose that in example 10, you wanted to find the instantaneous velocity of the object in t equals 1. Just as you can approximate the slope of the tangent line by calculating the slope of the secant line, you can approximate the velocity at t equals 1 by calculating the derivative of s at t equals 1. It says, in general, if s equals s of t is the position function of an object moving along a straight line, then the velocity function object at time t is v of t equals, the limit is delta t approaches 0 of blah, 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 blah. So what the heck did they just say? They said something very, very important. They said velocity, which is v of t, is equal to s prime of t. Find the derivative of the position function is the velocity function. Okay, the derivative of the position function is the velocity function. So if you want to know how fast something has traveled with direction, which would be velocity, find the derivative and evaluate the number. So let's look at this right here. Let's just look at this example. If I were to find the derivative, s prime, which would be equal to v, the velocity function, well, the derivative of negative 16t squared would be negative 16 times 2t to the first, right? The derivative of t squared is 2t to the first, plus the derivative of 100, which would be 0. So this would be, well, negative 16 times 2 is negative 32t. So what's the velocity at any given moment of time? It's negative 32t. So if we looked at the velocity at 1 second, it would be negative 32 times 1, which would be negative 32 feet per second. Again, it's always the derivative of velocity, or the derivative of position with respect to time. Position is measured in feet, with respect to time is measured in seconds. So that's how you're getting your feet per second on that one. So we just did an estimation by moving those points, those values, 2, 1.5, 1.1. We were getting closer and closer to the x value of 1. Notice our answers, the average rate of change was getting closer and closer to the velocity at the instant of 1 second, which was negative 32 feet per second.